This is Module 13, ICMP for the Cisco Network Academy Introduction of Networks version 7.0. ICMP messages are extremely important in any type of computerized system. We use ICMP messages to retrieve addresses to test for connectivity and many other chores as well. ICMP stands for Internet Control Message Protocol, and we have versions for both IPv4 and IPv6. They provide feedback about issues that are related to the processing of IP packets under certain conditions. ICMP v4 is obviously the protocol for IPv4, and ICMP v6 is the same for IPv6. The IPv6 version will also have additional functionality. Things that are common to both would be host reachability, or the destination or service is unreachable, or the time has exceeded, as in time to live for IPv4 or hop count for IPv6. ICMP v4 messages are not required and are often not allowed within a network for security reasons. The most common use would be host reachability. Using a ping command, we could ping to a destination IP address. The host trying to reach a destination would send out an echo request message. And this goes to the destination IP address. If the destination is there and it has not been blocked through a firewall, the destination will send back an echo reply. Many firewalls will stop a host computer from sending the echo reply so that a host trying to identify what addresses are in use and what hosts are available would not get feedback information to render that request a moot point. It can also give us that either a destination or a service is unreachable. An ICMP destination unreachable message can be used to notify the source that a destination or a service is unreachable. The codes will indicate what is the problem. So when we get a response from ICMP as to why we were not able to get there, in the message returning to us, the codes would indicate a general reason, such as for ICMP v4, 0 is that the network is unreachable. 1 is the host on the network is unreachable. 2 is that the protocol is unreachable. 3 would be that a port is unreachable. Besides just doing a straight ping to an IP address, you can also adapt the ping to include a particular port number. There are many programs that use this method as a port scan to find out what available ports are active in the network as a possible means of a reconnaissance attack and to break into the network. A few destination unreachable codes for ICMP v6 are 0, that there is no route to the destination. 1, communication with the destination is administratively prohibited, firewall or access list, some type of blockage. 2, The request is beyond the scope of the source address. 3, the address is unreachable. And 4, the port is unreachable. You'll notice that they are very similar, but there are slightly different codes for the messages returning to us, such as port A3 for port unreachable in ICMP v4 and A4 for port unreachable in ICMP v6. Time exceeded is a very useful thing in any network. We do not want packets to keep traversing around a network if the destination is unavailable. In IPv4, we have a time to live field. At each router, the time to live field will be decremented by 1. When it reaches 0, it will return to us that we have a time exceeded message. ICMP v6 also sends a time exceeded message. Instead of a time to live field, ICMP v6 uses a hop limit field to determine when the packet cannot reach a destination. As we can see in the diagram, that we would get a TTL expired in transit reply. This time exceeded messages, they are used by trace route, where at first the time to live field will be 1. When it gets to the first router, it will be decremented to 0, and the time exceeded message will be sent back. The time exceeded message usually has in it information about the device replying that the time has been exceeded. Many times we can use the information from the responding device to trace the route a packet would take through a network. ICMP v6 has new features and improved functionality that are not found in ICMP v4, as version 4 was developed 40 to 50 years before version 6. It has in it 4 new protocols as part of the neighbor discovery. You have ND or NDP, neighbor discovery or neighbor discovery protocol. The 4 messages would be RS, RA, NS, and NA. Messaging that goes between an IPv6 router and an IPv6 device will include dynamic address allocation. RS standing for router solicitation, RA standing for router advertisement. Messaging between IPv6 devices, including duplicate address detection or DAD and address resolution, are as follows: neighbor solicitation or NS and neighbor advertisement messages. You will notice in a later course when you put on an access control list on an interface, if you are using IPv6, it will automatically allow router solicitation, router advertisement, neighbor solicitation, and neighbor advertisement, as this is crucial to the workings of ICMP v6. It also includes the redirect message, which has similar function to the redirect message that is used in ICMP v4, which will redirect the message to another IP address. In this example, we can see the router will send out an RA message, and these are automatically enabled, and every 200 seconds to provide addressing information to all IPv6 enabled devices. The router advertisement message can include the addressing information for the host, such as the prefix, the prefix length, a DNS address, and a domain name. Any host that is using stateless address auto configuration, or SLAC, will set its default gateway to the link local address of the router that sent the router advertisement. As we can see in the diagram, the network that we are on is the 2001:DB8:ACAD:1. A link local address of FE80::1 has been configured. The address of R1, from that we would use the 2001:DB8:ACAD:1. The PC using SLAC will use its MAC address as well as inserting FFFE and the flipping of the 7th bit to create its own unique IPv6 address. It will also automatically create its own link local address, but it will use the link local address FE80::1 that is advertised by R1 in the RA message as its default gateway. The IPv6 enabled router will also send out a RA, or router advertisement message, in response to a router solicitation. When the PC is turned on, or when we tell it to get an IP address for IPv6, it will send out a router solicitation message, essentially asking if there is a router out there that can provide information about the network. So in this figure, PC1 sends a router solicitation message to determine how to receive its IPv6 address information dynamically. It can do it via SLAC, stateless, or stateful. R1 replies to the RS with the RA, the router advertisement message, essentially saying, this is my IP address, and this is how you can build your IP address. In our case, for this diagram, PC1 sends out the RS message. Hi, I just booted up. Is there an IPv6 router on the network? I need to know how to get my IPv6 address information dynamically. R1 will reply with an RA message. Hi, all IPv6 enabled devices, I'm R1, and you can use SLAC to create an IPv6 global unicast address. The prefix is 2001:DB8:ACAD:1:/64, and use my link local address of FE80::1 as the default gateway. If you wish to try this in Packet Tracer, all you need to do is connect a router to a PC. It can go direct with a crossover cable, or it could go through a switch. Put an IPv6 address on the router interface, a link local IPv6 address on the router interface. Enable IPv6 using the commands to turn that on, IPv6 unicast routing, and tell PC1 to get an IPv6 address. You will find that IPv6 will assign an address to PC1 with the default gateway of the link local. This is the easiest form of receiving an IPv6 address. The device assigned a global IPv6 unicast or linked local unicast address may perform duplicate address detection, or DAD, to ensure that the IPv6 address is unique. In Cisco equipment, because the PC will use, or the router will use, a MAC address adapted to create the IPv6 address, DAD is not normally required. Using Windows, which generates a random number for the last 64 bits of the IPv6 address, there is the remote instance where a duplicate address could be created. To check the uniqueness of an address, the device will send an NS message with its own IPv6 address as the target. Most people would see this as sending a message to themselves. But since this is going out onto the network, all other hosts on the network think that somebody could be looking for them. They check the message. If the address is the one that they are using, they respond like they normally would. This tells the requesting system that that address is already in use and it would change its address to accommodate that. So if another device on the network has this address, it will respond with a neighbor advertisement message notifying to the sending device that the address is in use. DAD is not required, but RFC 4861 recommends that DAD is performed on unicast addresses. To determine the MAC address for the destination, the device will send an NS message to the solicited node address. You are already familiar with the ARP request in IPv4, sending a message to the IPv4 address requesting its MAC address. The message will include the known targeted IPv6 address. The device that has the targeted IPv6 address will respond with a neighbor advertisement message containing its Ethernet MAC. As you can see, ICMP for IPv6, instead of using ARP, is using the neighbor advertisement and the neighbor requests or the neighbor solicitation message to get that information that ARP got through the ARP request. In this figure, R1 sends a neighbor solicitation message to 2001 DBA ACAD :1::10 asking for its MAC address. So we will send a neighbor solicitation message, which is listed as 1, and the PC will respond with a neighbor advertisement message. These two replacing the ARP request in IPv4. Ping and trace routes are two common features that are widely used to check connectivity to a destination. The results that we get from these are normally saved so that at a future time it gives us data as to the workability and the speed of our network connections. The most common is the ping command, and it is an IPv4 and IPv6 testing utility that uses ICMP echo request and echo reply messages to test the connectivity between hosts and provides a summary that includes the success rate and average round trip time to the destination. As we can see in the example, we had 4 success out of 5, which is not uncommon for the first time that we ping. And it tells us that we have an 80% and the round trip time is 1 millisecond. At a future date, if you've received a complaint that the network is not functioning as fast as it should, this kind of data can be returned to see if the original data, being 1 millisecond, is different than the current data. If a reply is not received within the timeout, the ping provides a message indicating that a response was not received. As we can see in the example, the period indicates that that was not received, while the exclamation point indicates that it was received. It is common for the first ping to time out if address resolution, ARP, or neighbor discovery needs to be performed before sending the ICMP echo request. Ping can be used to test the internal configuration of an IPv4 or IPv6 on the local host. To do this, we can ping the local loopback in IPv4 of 127.0.0.1 or ::1 for IPv6. If I receive a response from either the 127.0.0.1 or the ::1 for IPv6, this indicates that the IP is properly installed on the host. It tells us that the protocol stack and drivers for our network interface card are installed and working. If we have an error message, this may indicate that the TCP IP is not operational on the host. This could be a problem with the loaded drivers or the network interface card. A common practice is to ping the default gateway to make sure that we have a connection to our exit interface. The default gateway address is most often used because the router is normally always operational. The successful ping to the default gateway indicates that the host and the router interface serving as the default gateway are both operational on the local network. And as you can see in the diagram, the host would send an echo request and the router returns an echo reply. If the default gateway address does not respond, a ping can be sent to the IP address of another host on the local network that is known to be operational. Pinging a remote host would tell us that we can get from our network to another network. A local host can ping a host on a remote network, and a successful ping across the internetwork confirms communication on the local network. Many network administrators limit or totally prohibit the entry of ICMP messages. Therefore, the lack of a ping response could be due to security. Doing a trace route, which uses the same protocols as ping, with the addition of either a time to live or a hop count, trace route or trace RT, is a utility that is used to test the path between two hosts and provide a list of hops that were successfully reached along that path. Traceroute provides round-trip time for each hop along the path and indicates if a hop fails to respond. An asterisk is used to indicate a lost or unreplied packet. The information can be used to locate a problematic router in the path or may indicate that the router is configured not to reply. You can modify the trace command or trace route command to send different packet sizes and make it much more adaptable to test different configurations along the path. Traceroute makes use of a function of the time to live field in IPv4 and hop limit field in IPv6. In the layer 3 headers, along with the ICMP, time exceeded messages. The first message that is sent from Traceroute will have a time to live field value of 1. This will cause the time to live to time out at the first router, and then this router then responds with the ICMP v4 time exceeded message. Traceroute will then progressively increment the time to live field to 2, 3, 4, and continue on for each sequence of messages. This provides the trace with the address of each hop as the packet's timeout further down the path to the destination. Many network administrators do not allow Traceroute to work in their network due to security. The time to live field continues to be increased until the destination is reached or its maximum incremented to a predefined maximum, which can be set with the extended functions of Traceroute. This concludes Chapter 13, covering ICMP.